so in our previous lectures, we have studied the projection, then we have done projection of line, and then we have done projection of lamina. The lamina are actually two-dimensional object. No third dimension is there. So when you have the third dimension, then the lamina has become a solid. So these are lamina is also a practical thing. You can make lamina by taking a paper cutting, as the paper cutting has the negligible width, so it can be taken as lamina. But here we will take the solids. Okay, now as you can see in my board that there are solids. So prisms and pyramid. Solids can be broadly classified as prisms and pyramid. So you can, as you can easily see, that in case of prisms here, so there are two similar bases, okay, parallel and similar bases. These are called base. Base means the on which the solid will be resting on, so that will be called base. So, and that solid will be named as the shape of the base only. So prism means it will have two parallel bases and it will have a number of rectangular faces. Okay, they are called faces. So they are called number of faces, and that's solid will be named by as per the shape of the base. As per the shape of the base. So as it is a triangular shape base, so it will be a triangular prism. Then it is a square shape base, so square prism. Then pentagonal prism. Then hexagonal prism. Okay, so they are like the prism. And this is the cylinder. Cylinder will got two similar bases also. That is the circles. Two circles will be there, and another type of solid. There the base or a single base will be there, and the top point will be there. This is called apex or vertex. So in case of cone, we will have a circular base, and and that point is called apex or vertex. Then it is called, as the shape of the base is triangle, so triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. And for difference between prism and pyramid is that prism has got two similar bases, but pyramid has got only one base, and it has a number of rectangular faces, and the number of rectangle will be the number of sides of the polygon. As 5 number of sides here, pentagon means 5 sides, so 5 number of rectangular faces will be there. And here also a number of triangular faces are there. See, the faces are shaped like a triangle, so there are triangular faces. So again, for pentagon 5 number of triangular faces, for hexagon it is 6, for square it is 4, and for triangle it is 3. Okay, so they are like that. There are more and more pictures of the solids. So this is square prism. As I was telling you that these are called the rectangular faces. It is top face and it is bottom base. And for pyramid, I will have a apex, and the slant edges, actually the triangular faces. The edges of the triangular faces are called the slant edges. Okay, slant edges. So again, the number of slant edges are equal to the number of sides. For 4 it is 4. For pentagon it is 5, like that. And this is cylinder, two similar bases, circular bases. And for cone also, it will have a circular base. But in case of pyramid, the point of apex and the corner of the bases are joined by slant edges. But in case of cone, that line which joins the apex with the circumference of the base circle, they are called generators. Okay, for cylinder or cone, both are called generators. Though the number of slant edges are finite, for square it is 4, for pentagonal pyramid or it is 5, like that. But here the number of generators are infinite. Okay, we cannot count the number of generators. There are infinite number of generators are there. Okay, next, and when the solids are cut by cutting plane. Okay, so in this case you can see in my right hand side that this is actually a square pyramid and this is actually a cone. They are cut by cutting plane parallel to the base, isn't it? Parallel to the base. So two squares are produced. One base square was already there, and after the cutting, a small shape square has been produced. And here also small shape circle is produced other than the base circle. So they are called first term solids. Okay. when the cutting plane is parallel to the base, the cut portion is called first term. The name is also written here, first term solids. Okay, first term solids. And here the position of the cutting plane is inclined to the base, isn't it? Inclined to the base. So that solid is called truncated, though it is not written here. If you want, you may note it down. Truncated, TRUNCATED. So they are truncated solid. When the cutting plane is inclined to the base, truncated, and when cutting plane is parallel to the base, they are first term solid. FRUS TUM. So there are more pictures are being shown here. You can. There are actually different positions of a cone. We will do problems actually by different positions of the cone. Here is the different positions of a cylinder. Here again different positions of a cone. Here again it is a cylinder. Okay, so there are different positions. They are inclined with some, when the base is inclined at some angle with HP, inclined at some angle with VP. They are shown. Okay, so we will do the problem now. More and more figure I am showing you to make you understand more. So here are more pictures. They are the pyramids. As you can see, this top point is called apex, and they are called slant edges, and they are cylinder cone. Actually, these three solids are called solids of revolution. Please hear me carefully. These three solids are called solids of revolution. Why it is called solids of revolution? Because see, for a cylinder, if I take a rectangle, and keep that vertical axis fixed and rotate it, then the cylinder will be produced, isn't it? If we rotate a rectangle about its vertical side, kept fixed, then it is a cylinder will be generated. For cone, we need a right angle triangle, isn't it? And if we keep that perpendicular side as fixed and rotate that cone, or rotate the right angle triangle, then cone will be produced, isn't it? And then sphere, we need a half circular lamina, isn't it? We need a half circular lamina, and by keeping the diametral axis fixed, if we rotate that half circular lamina, then sphere will be produced. That's why cylinder, cone, and sphere are called solids of revolution. Okay, so they are the broad classifications of solids. Just I have told you. Now I will draw a projection. Okay. Now here, draw the projection of a hexagonal pyramid. Projections, that means three views will be required, as we are discussing during the lamina, that front elevation, plan, and side elevation is possible. Both right hand side elevation and left hand side elevation are possible. Okay. So draw the projections of a hexagonal pyramid of 30 mm base sides and 60 mm axis height. Base of the hexagon is resting on OHP, and two edges of the hexagon are parallel to VP. So here, the condition is said that the condition is given that base of the hexagon is on the HP, so it is on the HP, and two edges of the hexagon, see, the two edges of the hexagon are parallel to the VP. So parallel to the VP means parallel to the ground line. So firstly, you have to draw the hexagon like by making two sides parallel. Okay, so that can easily be done. You can draw the hexagon inside a circle, which has already been taught. And also you can draw by drawing a horizontal line of 30 mm, then taking 100 to 20 degree angle. So in both the ways, that hexagon can be drawn. I am not going into details the construction of the hexagon. I will do the construction of the full solid in details. So then we need to draw a horizontal line, that will be our ground line. Okay, so ground line is given. You can name that as XY, X and Y. This is the ground line. Okay, so as there is a pyramid, now you can see, let me go back to the pyramid. Okay, see a hexagonal pyramid. Now if the hexagonal pyramid is viewed from the top, see the apex will go on the center or the centroid. We are teaching in the engineering mechanics class centroid, concept of the centroid. So that apex point if we view it from the top, the apex point will go to the centroid, and that centroid will lie on the geometrical center of the hexagon, isn't it? So a number of slant edges will be there in the top view when you're viewing from the top. So that slant edges will be seen here, not the hexagon. So hexagon with its slant edges will be seen, and to draw the slant edges, you need to just firstly give that name A, B, C, D, E. There are number of sides A, B, B, C, C, D, D, E, F, and F, A. Now you have to join A to D. Then you have to join E to B. Okay. Lastly, you have to join F to C. Then those points will automatically meet at a single point O. So that's how the views of the slant edges, top views of the slant edges are found. Okay, so you see, just if you are viewing from the top, then a similar kind of views can be obtained. Now, how to draw the front elevation or front view? Okay, in order to do that, what you have to do, you have to take projection from all the points. Okay, from F, I have taken a projection. So A and E will lie on the same vertical line, and that is the case for D and B also. D and B will lie on the same vertical line. So you please check it while you are drawing. Please check it that whether E or A and D or B are lying on the same vertical line or not. So if not, then you have to draw the hexagon again, because that has to be the case actually. Now, so to take the axis, to get the axis, so height cannot be taken from anywhere, isn't it? Height cannot be taken from anywhere. Height can only be taken from the geometrical center point. Okay, isn't it? So from O, you need to draw a projection line up to the ground line. Now from that ground line, we have already known how to draw a axis line. Axis line is a chain line. Okay, we have already known how to draw it. So that draw a chain line. Okay, and take the height of 60 mm from base. Okay, so take the height of 60 mm from the base, because the base is here. For the top view, that O point is here, but from the front view, the O point will be some distance from the base. So take a point, let us say at 60 mm from the base XY. And now you have to join. I'm using different colors. So, sorry. Let me join first. Then I will give the names. So all the points are joined. Now we have to give names here. So this point is F dash, and the next point is A dash E dash, because A dash will come first. If you are viewing from, I'm telling you why A dash is coming first, because for the front view, the observer is here, viewing from here. Okay, so A point is coming first, then E. So that's why A dash comma E dash. Next point is B dash comma D dash, and the last point is C dash, and this point is O dash. Now you see, now I have to check whether the slant edges are continuous or hidden. So the observer is here, viewing from here. Now you see, when observer is viewing from here, OF will be, OF is boundary line, so that has to be a continuous line, and the same case is true for OC also, which is the boundary line, so that has to be a continuous line. And when the observer is viewing from here, now I see OA is come to the front of the observer, so OA will be a continuous line, but OE will go to the back side. So OE has to be shown with dotted line. Okay, the concept of the dotted line or hidden line, you have learned it from in the types of line. So continuous line, hidden line, chain line are there, or dotted line. So dotted line So the OE line has to be shown with dotted line, but our convention is if two slant edges overlap, so here in this case OA and OE are overlapping with each other, so we have to show the continuous line. Okay, we have to show the visible edge, not the dotted line. So they are overlapping with each other. So the first, so the slant edge which can be seen from this view will have to be shown by continuous line. So that is the case for this slant edge also. So this slant edge is representing both OD and OB, but OD will have to be shown with dotted line, but OB is to be shown with continuous line. So as OD is coming in front, so that has to be shown with the continuous line. Okay. Now, so this is the front elevation and plan, or front view or top view. And now you will draw side view, okay, or side elevation. So how to draw the side elevation? In order to do that, so the distance between the XY line and the O point is not fixed. You can take any suitable distance. Now, to draw the side view, you need to draw a vertical line here. Okay. Again, the distance has not been mentioned, so you can take any suitable distance. Okay. Now, to draw the front elevation or front view, we have taken projection from all the points. That same case will have to be done for the side view also, side elevation. That is, through all the points, you need to take now the horizontal lines. That is, E or D will lie on the same horizontal line, then FC will lie on the same horizontal line, O also, AB will lie on the same horizontal line. Okay. Now to draw the side view, what is to be done now? Here you have to draw 45-degree inclined lines. Okay, so this line is 45 degree. With the 45-degree set square, that can easily be done. That is not a difficult thing. And from the next point also, you need to draw another 45-degree inclined line. And from the last point, you need to draw another 45-degree inclined line. So the question is, why the lines are drawn at 45-degree inclined lines? Now you see, yeah, in this case, okay. For the side view, why the lines are taken at 45-degree incline? Because now you see there, so that shadow is obtained on here vertical plane, and the shadow we are going to draw here will be obtained here on this auxiliary plane, isn't it? And these planes are inclined at 90 degrees with each other, isn't it? 90 degrees with each other. That means for that view, the observer is here, and observer is at 90 degree for this view. So in graph we can say that if you rotate the object by 90 degree exactly from this view is obtained, isn't it? If the object is being rotated, I'm repeating again, if the object is being rotated by exactly 90 degrees, so this view is obtained. So the concept is that while we are drawing 45-degree inclined line, 45-degree inclined line means we are using a 45-degree inclined mirror, okay, to rotate the object at 90 degrees. So that's why that 45-degree lines are drawn, because to get that or to rotate the view or to get the shadow at 90 degree, the mirror is to be located at 45 degrees. So that's how the 45 degree lines, that's why the 45 degree lines are. So here is the projection of O. So from that point, axis line, the axis height will have to be taken. Axis line has already been taken. So here if you can draw a horizontal line, so that view is your, so in the side view, the points will always be denoted as double dash. In the front view, it is denoted as dash. In the side view, it will be denoted as a double dash. So the name of this point will be, so this first, this observer is here. See, for this view, observer is here, and for this view, observer is here. So the observer position is changing as 90 degree. So that view is being rotated by 90 degree. That's why 45-degree mirror are used. Okay. So that point will be, first E dash will come, E dash, comma, D dash. Next, this point is F dash, double dash, sorry, F double dash. comma C double dash. As observer is here, so F will come first, then C. Then the observer is here, so A and B. So A double dash, comma B double dash. That's how the all points are obtained. Now, again I am saying, see here we have drawn the axis height. Then we have taken the axis height from the projection of O, but the edge F and C are coinciding with the axis, and when observer is viewing from here on this side, this line edge OF will come in front of the axis line. So when that continuous edge is coming in front of the axis line, so in that case axis line will not have to be drawn, only a continuous line will have to be drawn, which is representing OF, because you see that line represents actually three lines: the OF, axis, and also OC. So axis will have to be shown by chain line, and OC will have to be shown by hidden line or dotted line, and OF will have to be shown by continuous line. But on a single line, you cannot show all three of them, so you have to show only one. So we will show only the continuous line. Okay. Next, we have to join this edge, and we have to join this edge. So this is the complete projection of the hexagonal pyramid. The problem, the complete projection of the pyramid has been drawn here. Now, the next problem, so this is our first problem we have done. Now the next one, draw the projection of a pentagonal pyramid, base 30 mm edge and axis 50 mm long, having its base on the HP. HP means it will be resting on the HP, as is the case here, and an edge of the base parallel to the VP. Okay, so this concept is in this situation is important, that an edge of the base is parallel to the VP. That means you have to draw the pentagon like that. Okay, firstly you have to take a edge, this edge, parallel to the horizontal line, parallel to the XY line. Okay, then by making 108-degree angle, just finish the pentagon. All of you have known, I believe, how to draw a pentagon. I have shown you previously when you were drawing the involute of a pentagon. We have known how to draw a pentagon. So draw the pentagon by 108-degree angle. So once the pentagon is drawn, you have to find the geometrical center of it. Okay, isn't it? You have to find the geometrical center. How it is done? So take the midpoint of BC. Okay, take the midpoint of BC. So the base edge is 30 mm given. So mark a point from C up to 15 mm. Okay, then mark another point from A, 15 mm. Okay, so from that point join E. Okay, and from that point join the opposite corner. So here in this case D. So those two medians which we will cut at O. So that's how O point will be found. Okay. Okay. I believe you have understood how to find that point O, finding the midpoint, then joining it to the opposite corner. Again, find the midpoint, join with the opposite corner D. So then the two lines will intersect at the geometrical center O. So once the O point has been found, what you have to do now, you have to join all the points of the corners starting from A, B, C, D, and E with O. So then the top views of the slant edges will be obtained. Okay. Now the next step, similar to the similar to the hexagon just we have done. We have to take projection lines from all the points. So A, E, D, C, and B. So B and O will coincide again, and as the B and this line is also the axis. This is the projection of both from point B and point O. So axis height will have to be taken from this point. So take the height of 50 mm. So that height will have to be taken as 50 mm. Okay, from the midpoint B. Okay, now the points you have already drawn. So join the points with O. So these two are boundary lines. These are boundary lines, isn't it? So these two are boundary lines, so those has to be continuous line. Now you see, for the front view, observer is here, observer is viewing from this side, isn't it? Observer is viewing from this side. So OB will come first, then the axis, so that OB is to be drawn here or represented here, and the boundaries are obviously dark. Now you see, when observer is viewing from here, both E and D point are going to the back. So they are invisible to the observer, isn't it? When the observer is here, A, C and B are can be seen. You can easily understand that when observer is viewing from here, both 3 points, all the 3 points can be seen, but not D and E. They are going to the back. So the lines, so the slant edges will be going to the back also. So that has to be represented by dotted line. So O dash E dash and O dash D dash, both the slant edges have to be represented by dotted lines or hidden lines. Okay. Now the side view. Okay, so draw the side view. Again, you have to take the projection lines from all the points. So E and D will coincide. O, projection from A and C will coincide. Okay, A and C will, if you draw a horizontal line, then you'll find that A and C will coincide. Then projection from B. Now 1, 2, 3, 4. So 4 lines have been obtained. Now you have to decide through which point you will take the axis height. You will take the axis height. So projection of O. So you need to draw 4 45 degree lines. One from O1, from C another, and from B another. Okay. So from O line, the 45 degree line drawn from O is this one. So from this point, you need to take the axis height. Okay, you need to take the axis, and so for side view, the observer is viewing from this side. So O point will be a separate point than from O, because they are not at that same horizontal line, isn't it? So from O, just draw axis line, and the height can be taken from here. If you draw a horizontal line from O dash, automatically O double dash point will be found. Here it is represented by O1, but you can represent it by double dash also. That is also correct, and O double dash is also correct. So that point is the E and D. So E comma D. All the things are not written here. I'm writing this double dash comma D double dash. This point is A comma C, A double dash, C double dash, and this point is B double dash, isn't it? And this point is O double dash. So axis height. So it is not overlapping with anything, so that axis can be drawn here, and this line is continuous, and boundary is continuous, and OA and OC will overlap. So OC is to be the dotted line, and OA is to be the continuous line. So again, as I have already said, that continuous line is to be shown. So the continuous line. Now you see one thing, that other than the 45 degree lines, here a arc is drawn, isn't it? The arc is drawn. So how to draw the arc? So arc are drawn by making center from here. So 45 degree line means the distance from this point to this point will be equal to the distance between this point and this point. So that's why arc can be drawn also by making center right here. So the first radius will be this one, second radius will be this one, third will be this one, and the fourth radius will be this one. So you can either draw 45 degree lines, or you can draw arcs also. So in both the ways, the curves can be drawn. So I have shown you two problems here. You have to do both of them.